Okay, so here's a second example of a complex circuit. So we have a 120 volt power supply. Our R1 is 8 ohms. Then it branches, and in the first branch there's another branch. R2 is 9 ohms. R3 is 18 ohms. In this other branch we have an R4 of 4 ohms and an R5 of 8 ohms. Okay, so if you didn't draw this already, if you didn't watch the video previous to this one, then pause the video, draw it now, and then make your chart. So in their chart, we need a V total, an I total, and an R total. You need a V1, an I1, and an R1. A V2, an I2, and an R2. And then a 3 column. And then the ones I combine, I always put right after what I've combined. Oh, I guess I probably, wait, we didn't combine them. Stop the chart. We better simplify this. Sorry, I had already combined it in my head, but we should probably do it together. What ones are we going to combine first? Well, hopefully you can see that these two are parallel to each other. So we can combine R2 and R3. Hopefully you can also see that these two are in series with each other. So if you follow the current, R1 is by itself, all the total goes through it, it's in series. But here it branches. So this branch, R2, 3, is in parallel with this branch, R4, 5. But R4 and 5 are in series with each other, R2 and 3 are in parallel with each other. So we can simplify our circuit by leaving R1 where it is, and then this is R2, 3 right here, and then in our next branch, R4, 5. R4, 5 is easy to get, they're in series, so we can just add them together. So R4, 5 is just going to be equal to 12 ohms. R2, 3 is in parallel, and so in parallel we have to do 1 over. So we would do 1 over R2, 3 is equal to 1 over R2 plus 1 over R3. So that's equal to 1 over 9 ohms plus 1 over 18. Common denominator is 18, 2 over 18 plus 1 over 18, 3 over 18. Flip it, R2, 3 is going to be equal to 6 ohms. So back here, this is equal to 6 ohms. But I'm not finished because this is not still a pure series or a pure parallel. It's still complex. And so now in my next step, I would have to put together R2, 3 and R4, 5. And so if I do that, then my circuit has R1 up here. This will be R2, 3, 4, 5 right here. And this is still R1 equals 8 ohms. Whoops, off the screen. So now to find R2, 3, 4, 5, these two are in parallel, so I have to do 1 over again. So 1 over R2, 3, 4, 5 is going to equal 1 over R2, 3 plus 1 over R4, 5. So 1 over 6 plus 1 over 12. See the nice numbers I picked for you? That's 3 over 12, which reduces to 1 over 4. So R2, 3, 4, 5 is equal to 4 ohms. Now I can build my chart. So, as I said a minute ago, we have V total, I total, R total, V1, I1, R1, V2, I2, R2, V3, I3, R3. My next column, I would make 2, 3, because I would put it right after my 2 and my 3. Okay, so this column I will make 2, 3. Then I would do 4, 4, 4, 5, 5, 5, and then 4, 5, 4, 5, and 4, 5. And then finally 2, 3, 4, 5. 2, 3, 4, 5, and 2, 3, 4, 5. Okay, and I guess what I didn't say was, if you look at this most simplified circuit, it's now completely series, so we're good. Okay, we don't have to simplify any further. So now we fill in our knowns. So we have 120 volts here. R1 is 8 ohms. R2 is 9 ohms. R3 is 18 ohms. R2, 3 we found, it was 6 ohms. R4 was 4 ohms. R5 is 8 ohms. R4, 5 we found to be 12 ohms. And R2, 3, 4, 5 we found to be 4 ohms. Okay? So now that we have all of that, we can find our R total. But remember, you find your R total by going to your most simplified circuit. It's in series, so you can just add up the 8 and 4 and get 12 ohms. 120 volts, 12 ohms, that means I total is 10 amps. Then again, we go to our most simplified circuit and we say it's in series, and in series current is the same. So I1 and I2, 3, 4, 5 should be the same as I total. Not all the I's, just I1, 10 amps, and I2, 3, 4, 5, all the way down here, 10 amps. Once we have that, I can get this voltage, 40 volts. I can get this voltage, 80 volts. 40 and 80 add back to give me 120 the way they should. So now my most simplified circuit is done. Now I have to step backward and say, okay, I replaced R2, 3 and R4, 5 with R2, 3, 4, 5. And these two were in parallel. And in parallel, voltage is the same. So V2, 3 should be the same as V4, 5, should be the same as what replaced it, V2, 3, 4, 5. That was 40 volts. So on my chart, V4, 5 needs to be 40 volts, and V2, 3 needs to be 40 volts. Okay? So V4, 5 is 40 volts, 40 divided by 12, 20 over 6, 10 over 3, so 3 1/3 amps. Sorry, it didn't work out to be all that pretty. And then for 2, 3, 40 over 6, so 20 over 3, so 6 2/3 amps, and it should add together to give me 10 amps, and it does. Okay, so this circuit is done. Now I step back one more time. R3, 4 was replaced R3 and R4. They are in series. R4 and R5. And in series, current is the same. So I4 should be equal to I5, should be equal to I4, 5. So I4 should be 3 1/3 amps, and I5 should be 3 1/3 amps, and so then I can get my V's. Then I need to do the same. Sorry, I'm going to run out of time, so I just wanted to flip up here. I need to do the same with my 2 and 3. 2 and 3 were in parallel. In parallel, the voltage is the same. So V3 should be equal to V2, should be equal to the V that replaced it, V2, 3, which was 40 volts. So 40 volts here and 40 volts here. And then I can find my I's by dividing 40 by 9 and 40 by 18. It's going to be messy, but I can still do it. What is that going to be? 4 point something. 40 divided by 9. 4.4 repeating amps. And this one, 40 by 18, that should be 2.2 repeating amps, which would give me 6.6 repeating, which was what this guy was. And for my voltages for V4 and V5, 3